C7.4, calculating energy changes. This is using bond energies, and we'll go back to the example that we used in 7.3 with methane burning in oxygen to form carbon dioxide and water. If we write the equation, which is usually what you're given in the exam, and you may well be asked to balance it, you'll know that 1 mole of methane will react with 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water. Okay? That's important when we come to draw this out. Now, the objective here will be to calculate the overall energy change of this reaction. And you will be given a table of information here of bond energies, bond strengths, which you will need to use. Okay? So the information you'll be given is usually the equation and the bond energies. Step number 1, draw out your molecules and in the correct numbers as well. So 1 methane, 2 oxygen, 1 carbon dioxide and 2 water. Showing every single bond in the molecules. Each one counts. We then need to look at the 2 halves of this equation. Bonds that need to be broken are 4 carbon-hydrogen bonds there and 2 oxygen double bonds, which are here. And the bonds that will be made or formed at the end of the reaction to make your products are 2 carbon dioxide bonds, so 2 carbon oxygen bonds, 1 and 2 there, and 4 OH bonds, 1, 2, 3, 4. Okay, so we take the equation, we draw out every single bond, and then we work out the bonds to be broken and the bonds that will be formed. The bonds that are broken require energy, so we have to put energy in to break these. That's the activation energy. The energy that is released when the new bonds are formed is here, when these bonds form. Okay. Moving on, using the bond energy then, which will be given in the question. Divide your answer paper up. Energy needed to break the bonds in the reactants and energy released when new bonds are formed in the products. 4 lots of carbon-hydrogen bonds, so that's 4 times 413 is 1652. So we refer to this over here, 4 carbon-hydrogen bonds are broken. And 2 oxygen-oxygen bonds are broken. So multiplying that up, it will give us a total of 2648 kilojoules of energy that we put into that reaction. So that's a positive. Energy released when new bonds are formed. We are going to form 2 carbon-oxygen bonds here. Each has a strength of 804, giving us a total of 1608. And we're going to form 4 OH bonds here, each one with a strength of 464 kilojoules. That gives us a total of 1856. If we add those together, that gives us a negative value because the energy is lost from the chemicals. Then it gives us an overall of minus 816 kilojoules per mole, and that is an exothermic reaction.